Hello. So, yes. Anyway, this time we have less people. Hopefully, more will join us. The pizza is coming soon. And yes, so this is our second part of SQL and database design workshop by C.R.E.A.T.E. And my name is Sadra. So, just a quick recap. We went over what is a database. We went over different data storages. We designed the database. We talked about relationships. And we designed this database. This time, so because we didn't get enough time last time, we're going to work with them this lesson. So you guys all have access to this website. And as you can see, the design has changed from last time. We now have the lesson 2 there. Yes?
Website is down for me.
Don't do it with HTTPS. It's HTTP. It's just this.
Your website isn't secure, man.
It's not, but I mean, I had only technically 1 week to build it, so it makes sense. But now we get to the fun parts of it. So we have this database, but this is just a schema. We don't have any records in it. We don't have any sort of information there. And even if we do, we don't know how to retrieve those information. So today, we're going to talk about those. We have 4 main operations in any database, especially MySQL. We have insert, update, drop, select. Drop has a different name in different database structures. We have a different name for it in MySQL specifically, which is delete, which all of these 4 are going to help us insert data, update the data, delete the data, and select the data. So pretty much English. I hope you all have the website open, because this time we're not going to actually wait. You guys can actually do all of the stuff that I'm telling you at the same time as I'm teaching it. So the insert command always looks like this. We don't have the pointer here. No. So, but I have this. So the insert into command, like, it has to be insert into. We can't have the into command it's not only insert. The keyword is insert into. Then we have the table name that we want to add information, but then we have this part. This part is telling which columns we want to add information to. If you're adding information to all of the columns, you don't need to put that part. But even if you're not putting information in even one part, even if it has the set default, you still need this to show this information is going to this column specifically. And then we have the keyword values, and these are the values that it goes to. So the other version of it is just this, which you're technically putting you're putting values for all of the columns. You don't need to memorize all of this. I'm going to give you a cheat sheet at the end of all of the insert, update, and delete functions, so you can actually work with them. But for now, actually try to insert one row of data to the show table. And if you want to know how it looks like, where is this? In this one, we want to add one show. Keep in mind, all of your constraints and restrictions that you applied before in creating these tables apply. And because you're using your own databases right now, each person has a different database, you might want to use the button to get the structure first. And also, if you remember the way that we coded this, the IDs are all auto-increment. So you technically don't need to put an ID. Did anyone do it successfully? Right now, the only way that you can know if you did it successfully or not is having the message saying command executed successfully. If you see that, it means it's added. If you want to see how you added it, you can use and then here you put the table name. Something to note? Yes. Select star from table name. Sorry, select. And usually for table names, column names, and all of those stuff that are not strings, they're variable names, we put this. It's not quotation. For my keyboard, it's on the bottom right, top left. I don't know what it's called, but it's very similar to quotation, but it's one quotation. It's not actual quotation. Yes. No, only day one for now. So in your day one, there are 3 buttons. One of them is reset the database. One of them is reset and create sample structure, and one is add sample data. Don't add sample data, just use the reset and add a structure, and then insert your data into it. Yes. So the structure is different command. If you want to see the structure of your database, you have show tables to show you the tables that you have, and if you use disk as a description and then table name, it gives you the structure, which is this one that I'm giving you right now.
So when we're inserting the shows, so I know the ID auto increments. Do we still need to give it one, or will it just automatically assign that?
Since it automatically assigns it, you don't need to give it. But since you're not giving that information, you have to choose which columns of information you're giving to it.
Okay, cool.
So the command structure is going to look something like the first one. So it's going to be table name as in show, the column 1 being, I think, title. So you start from everything after ID. So in this case, you just input information about type ID, title, directory, release date, rating, duration, description. And actually, if you just have the sample, you don't have the sample data and you just have the structure, you're going to run into an error. What is the error?
I mean, then you're going to have one fewer argument if you're actually.
Not that, because it auto increments it, so you don't need to give that information. You don't need to give it as the values as well. So the way this one works, I can show you. It's this way. Yes. What? Exactly. So that was the error that you are actually going to get. Here, if I'm going to show you how to actually add it, but here when you want to add it, one thing is type ID. Type ID is something related to another table, and we already set up the foreign key for it. So technically, you're not able to add a show unless you have a show type. Is that clear why we can't add it?
So just insert into show type first.
Yes. So because this one is getting connected to show type, you need at least one ID there to attach it to. So let's just go back here. So let me just actually show you how it's done. Insert into show type value. Where's my mouse? Where's my pointer? Since I'm not giving a value for the ID, I just click here and I just go with type. That should be type. Show type is the other table. And then, so that's what I was talking about. It's not quotation, it's not, but I don't know the exact name of it. If anyone knows, that would be very helpful right now. This symbol.
The squiggle? Or no, not the squiggle, sorry, hold on. Cross. No, no,
No,
that's
it's under possibilities.
It's for my keyboard.
single
It's
quotes, let's just say.
it's not single code. This one is single code. So this one in my laptop is top left. No clue.
It's the same key as this squiggle, but
Yeah.
it's the
It-
bottom of it. The alternative.
So let's just add this and see if it works. Hopefully I did the correct. Yep. So now we can actually see it. Let's start from. So the value is what you want to add. You can just put anything. So technically in show type, you're in the type part, you're just giving it a name. It can be like short movies, series, and those stuff. And as you can see, when I do the select star, it actually shows me the ID of it, and it shows me what I put there. Now I can use this ID to add a show. Now let's do that. It's going to be describe show. And you actually need those symbols around show because show is technically a keyword in MySQL. If you run describe show, it's going to give you an error. So you need those signs. Apparently our system doesn't like disk, so you have to actually write the whole description. But this is the database that we want to add something into. And let's just add show into it. Insert into show. What values do we want to give it? So the ID is auto increment, as we can see here. We don't need to add anything to it. Then we have type ID. So we just go up here. Again, we have to put those symbols next around the columns. And then title. Sorry. Title. This, if you write the whole describe, you're going to see it. I don't have enough space. It's not working? We all have the same database. and put the table name, which is shows. Yes, so it's actually show, and you need this sign around the show.
Oh.
So we are still adding these. Usually in a normal database, as Ness pointed out, we have the director outside this table, so it's another connection. Hi. Then we have rating. Something to keep in mind is when you're actually giving these information to the system, you have to make sure you follow the data types that you already put in. So you can't give you can't give a string to int, or you can't give an int to a string, and those stuff. So we have values being 1. That 1 has to be without any quotations or anything, because it's just 1. Then we have title being, something to keep in mind. In normal applications and programming language, we have double quotation for strings. But in all databases, the supported string symbols are quotation. Some of them support double quotation, but in most cases, it's just quotation. So let's just say, give me a famous movie or something. Nope. Doctor Who. Director, I have no clue. I'm going to put myself. Who? You know that I can't write that. Then release date. So this one has to support the formatting of date. But dates usually have this format. But usually you can't put this, so you have to put the quotations around this one as well, even though it's not a string. So I'm going to go with 2000, 10, 22. And then for rating, it was something between 0, 0 to 10, 0. And it's, as we can see here, it's a double. So we actually give it a double. Let's just say 9.5. Actually, I wouldn't give Doctor Who 9.5. Right now, I would give it 7.5. Then duration was int as in minutes. So I think each episode is 50 minutes something. And then description can be anything. Testing. No. Watching this series. And don't forget to close the bracket. Yes?
The release date is
1964. And then we do this. Successfully added. Select star from show. And we have it here. So this is how the insert works. It's a very simple command. And the way that we can have this is, let me just get back to this. So this only adds one data at a time. But if you want to have several rows added at the same time, you add a column, you add a comma here, and then you add another row of this parenthesis. And when you're done with all of the rows that you want to add, you add a semicolon. So just you go one line down, you put a comma here, another parenthesis with all of the values, and then semicolon. But all of the values that you give has to be corresponding to the column names that you already given it. Now let's just see how we can do update. The update command is this because, again, completely English, update set where. The where is the one that I have to talk about a bit more. Yes, question. So if you want to insert several rows at the same time, you do a comma here, then you add another set of values with parentheses below it. And when you're done with all of the values that you want to add, you add a semicolon. But in update, it's a bit different than insert. Insert, you're just adding something. But in update, you have to say which value you want to update. So this time, you have to give it a condition. That's where is coming from. That's a very weird sentence to say. Anyway, so the conditions here are just like normal programming, especially very similar to Python. We have equal, equal. I don't have any more space to write. We have equal, equal. Sorry, this time it's only equal. Bigger, lower, bigger than equal, smaller than equal. So something that is different than other programming languages is not equal is sometimes this, sometimes this, which is a very weird thing. I know. Can I actually write on this? Where is my? Yes. The pen is very bad. Okay, never mind. So you have to see which one is appropriate for your database. I think MySQL is actually using this one, the weird one, rather than the normal one. Or you can try both of them. So we have these. We also have a command that I think I used for 4 hours today, in. This condition says, if you give it a column, and then you say in, and a set of values, it checks if the value in this column is equal to any of those values in that set you gave. So exactly like how in work in Python. But let's get back to update. So update works similar to insert, but this time you just say which columns you want to change and which values you want to give it. If you don't have the where clause here, it's going to update any record in that table. It's not going to have any conditions. So let's just say we have update. I want to change my rating to Doctor Who this time. What I would say is I'm going to say set rating equal to this time. Should I go higher or lower? Well, let's just give it half a point. And then we do where. And how can I select this exact record? I just want to change Doctor Who. And imagine we have several other movies here as well. What conditions should I put there to make sure it's only Doctor Who? Yes? What do you mean date? So it should be in this form. Year, month, day. As a string, yes.
In this case, I don't know what sort of things you can do, but just like title equals Doctor Who.
Sure. Title equal as a string, Doctor Who. And yes, it's changed. But what if I have several episodes of one Doctor Who, and I want to only change one rating? I want to change a rating for only one of them. What is unique about each record?
Oh, the ID.
Yes. So you can actually change anything with the ID as well. So you can just give it ID and do this as ID 1. And this time, I watched a couple of more episodes and I don't like it really. So it's down to 7. and we can see if it worked. I'm going to talk more about conditions when we get to select, because that's where we're actually going to have fun. Now that we're actually working with update, I would suggest you guys resetting your database and then adding sample data to it. So just 2-click, and it should be a green message saying added. And let's just say select, and fair warning, don't do this command without a limit. So if you run this, your browser will crash. It's literally more than 10,000 records, and it's too much for one browser to handle. So at the end, add a limit of 10. Limit is a keyword that is used in SQL to show only the top 10 results, or top n results. We have in SQL Server, it's different. It's called top, but in MySQL, it's limit. So let's just run this. You get the first 10 items in it. And another thing, I don't know where these movies are coming from. Yes. It's not going to crash the website. The website is going to send nearly, I think, 5 megabytes of data, which is not big, but when it's going to be rendered like this in your browser is going to crash, or it's going to be super slow. Yes. The website can actually send all of this information, which is in the other database when we go to, it's nearly 200 megs, and it can send all of them in a second. But your device can't handle all of that at once. Yes. Duration is, as of the description of it, it's minute, so it's int. Any number would do. Any number above 0. What? So varchar, we talked about it last time. Varchar is a column with type string, and any number you put inside the parentheses of varchar means that's the maximum length of a string you're going to have. If you have only, so the difference between them is you can put any number, any text, because it's varchar, it accepts strings as well. So yes, anything would do. Because technically, because it's a string variable, it can accept anything. And if you don't have the part which is var, it has to be that length that you put it. Yes. Oh, select star from show table name, which is here somewhere. Oh yeah, it's here. So we know how to update, we know how to insert. These are, technically, you are going to use them, but they are not the reason that we are here today. Also, we have the delete, which is the simplest command out there. Delete from, you give it the table name, and then you give it a condition of which records to delete, and it deletes them. So I'll give you time to just delete one record and see if it's been deleted. My suggestion, if you're doing it with the sample data, remove the first row and then select star limit so you can see it getting removed. I'll give you 2 minutes for it. So I talked about it. The condition is the exact same conditions as we have in programming languages like Python or anything. But the structure of it is usually a column name, and then some type of operand, either in or any of the bigger equal, and those stuff, and then some values. If you're using in, this part has to be a set. If you're using equal, it has to be exact value. And I'm not too sure, but I don't think that SQL checks the data types. So you can technically do a comparison between a string and int. But Don't quote me on that. Did you guys delete something from the database? I'm going to give you another 2 minutes.
Still working on insert issue. It's not executing.
Usually the auto increment, it starts from at 1. That's why I was like worried at the point. So everyone deleted something? Not yet. You don't need to take pictures because I'm going to actually give you a cheat sheet at the end of this before we actually get into tasks. So everyone ready for some actual fun stuff? So before that, when you're done with your code, refresh your page, and if you go back to your dashboard, you're going to actually see the day 2 is now available. It should be available. The button works. Don't mind this part. That's not following my true false flag. But in this in the day 2 SQL queries, you have permissions on selecting and reading the data, but you don't have permissions on inserting or deleting data. So no modifying the data, you can just use it. Because it's a very big database, I couldn't copy it for everyone. Now, this is the part that gets fun. How so? So imagine we have a large database. The command select star from table name gives you any information in any column from that table. And you can actually use this. So if you have, let's say you have a Flask Python application, you have a personal website, and you're using SQL, MySQL as a backend database. You can still use the select star from table name and get information and then sort the information as you wish yourself over like with Python. But that's a very hard process to do because that's very time not efficient. Time not efficient is, anyway. So fun story, the database that you're going to work with today, I've been working on for the past 3 days, each day nearly 6 hours. And something that was wrong in my process I learned at the last moment was I wasn't using SQL. I was using Python to first filter the data and then put it into SQL, which is not time efficient. When I put it in SQL and then filtered it, it was way faster, and I could do it in like an hour or 2. So this works. You can get all of the information, then you can filter everything through Python. It's not time efficient. And it's very hard to combine information with Python rather than SQL. So this is what we're going to do today. This is the normal select. This is the general select command, which is exactly similar, but instead of star, we have column names. So you're telling it which column values you want. But that still is going to give you all of the database. Don't run this on the big database. Your browser will crash. If you put a limit at the end, it should work. So let's just try this with select. Oh, I forgot to show you this. Where's my... This is the database that we're working with today. It's a bit bigger than the previous one. And I can actually send this link in Discord. So this is the structure of the database that we're going to work with today. This is the IMDb database, the actual database, but in our design, because their design was something different. I'm going to send this link in Discord for anyone who, actually I don't have my Discord open. Okay. So this is a database that we're going to work with today. And right now, what table do you guys want to see the first top values of? Known for, okay. The link of this is now in Discord resources, if anyone wants. And now let's code. Select star from known for limit of 10. So this is the table that is there. Does it look good? It's the design of databases, especially the big ones, are not human readable in most cases. So these two are the IDs that we're going to work with. TT at the start of any ID means it's a title ID, and NM means it's a name ID. You know the database structure, I can show it again. But the known for database, what is it? What is it representing? It's representing a type of relationship right now between tables. Known for is a kind of relationship between two other tables. What type of relationship? Yes. Many to many between. Yes. That's why we can't technically read it, because it's just showing the IDs of records in title and records in name. We can still go get those information, but that's another query. Today, we're actually going to work with the stuff that technically attach all of this information into one thing, so we can actually read this information in a human readable form. So right now we have these, but maybe I just want the title ID. So this is how I do this one. We go with known for. Don't forget the limit of 10. And execute. So now it just shows these. I have a question for you. What happens if I do this? Are you in day 2? You have to go to dashboard and then go to day 2. The table is this. Test? Oh, okay. So, yes. If I change this to a string test, what would happen? Keep in mind, this one is string because it has quotation and not the other symbol. What would happen if I do this? Remember, select only gets columns there. It doesn't get conditions. It gets the column name, so it just shows those column names. It's not adding any conditions.
So I guess would be that it either shows no columns or crashes.
Let's see. This is a very weird implementation of Select, but it gives a lot of power to us. How? The reason, hopefully this is on, yes. So when we do a string there, like we give it a specific value, it just has one table or one column all being that specific value. The reason behind this is when we are doing more complicated stuff, we actually need sometimes to have one row, one column to be all specific value. What would happen if I do this and then do the test?
Your title ID called and then test.
Yes. So technically, in your output, we call this a result table. Technically, it's actually storing all of this in a result table. And it's just adding one column to that table with that value being tested. But this is not the only way we can use select. What if I want to only get values that are distinct? I only want to get unique values. And how does the distinct work is two different questions. So select distinct gives you unique values in those columns. But how does it check the uniqueness? Before I ran it, I want to get your ideas. If I run only the select distinct with one column, it's obvious. It's just going to give the unique values of that column. But what if I ran it with column 1 and column 2 with two columns? Would it return unique values of column 1 and then unique values of column 2? Or something else? Yes?
Shouldn't it return the unique values of the union of column 1 and column 2?
So a combination of them. Yes. That's exactly what happens with distinct. So let's run this on, let's run it on title start here. Select distinct and start here from title limit of 10. I get the 10 top values of uniqueness, but now let's just add start here and end here. So the end year for all of these ones are mostly none. So this is still a unique combination. But now, start here is from the title here. Where does it say that? Oh, if you go with one quotation, you're putting it as a string, which just prints it out. We have distinct values. It's the same one as around any of the tables that we were using before. So now we have order. Sometimes you want to order based on something, like order based on date. This is the order by. And then you tell it, do you want it to be ascending or descending? Something that I always struggle with. I don't know which one, so I test both to see which one is my desire. Now, this one I'm not actually going to test right now because we get to this one. So in this last one, we actually have the notation of where or condition. This is the part that it gets interesting because rather than getting all of the information in your application and then doing filterings on it, which I was doing today, stupidly, we can just use conditions. We can just say, give us the information from title that's any conditions? No. I'm going to go with title. This. Ooh. I'm going to explain what I did here as well. Did I misread this? Oh, primary title. Primary title. Oh, and this has to be like this. My bad. So apparently we don't have Doctor Who there. So what does that say? The like is very similar to n, but like gives you an ability to search for a pattern. What can you guess from these names that are here that the dollar sign stands for? Yeah, percent sign, sorry.
Substring and then A.
Yes, exactly. And what does this do?
A single character?
Exactly. So the only two type of, I think, from what I know, the only two type of pattern that it recognizes are percent sign and underscore, which underscore means one character being anything, and percent means any string length and anything technically. So let's search for a specific name. We don't have Doctor Who here. Let's see if we have. Since I know the data is big, we just go with the top 10. Oh, we don't have anything starting with the. What about with T? So it shows the stuff that are string and then A. So in this case, it shows the stuff that are sorry, it's this one. In this one, it starts with the stuff that are A and then any string. So this, any time that you get to this, it means anything. Before it has to be A, anything you put after it has to be after it. Now we have all of these tools. I'm not going to go over join command. This is your checklist. You can either go to the, not checklist, cheat sheet. This is your cheat sheet. You can either go to this QR code or the URL. They're the same thing. But from now, we're doing tasks. So you have a big data. I'm the data analyst, and I need data from you. You guys are going to give me that data from the database. Everyone got the cheat sheet? Sure. There are a lot of cheat sheets out there. You can even search yourself, MySQL cheat sheet, and it gives you all of them. But this one, when I was looking at it, it seemed good. For now, technically, I think I went over most of the commands there. One of the important ones is join that I'm going to go over after. So for now, let's go to the first task. The first task that me as data scientist I want the data from is I want the principles that are designed that are so principles in this database are roles that a person had in a specific movie. So I want to find the roles that user with ID NM all those zeros 1 has from the database. It should be a fairly quick and simple command. Yes. And since I can't actually read all of your results, just give me the number of commands you get, number of results you get. So I'm actually going to put this here so you can see it, and then I'm going to run my own command. How many records did you get? If you can count that day. It's not countable by hand. What? One, two, three, four, five, six. 6 zeros and then a 1, 1. So we have two parts. One part, I give you the name ID. The second one, I give you the name. Yes. Try again. Single equal. After the first part of this task, we go for a short break to eat and then we continue it. It looks a lot, right? But you can still see the end. What is the last? What is your last result? What is the ID of the last record you have? Are you sure that's what you're looking for? So, yes, for part 1, your code should result something like this, and the last record is this. I want to see the whole database, but only that filtered by that one column. Okay, I'm gonna show you the code for this one because it's a like we have more of it. Don't worry about it. So this is the code that I have, and it's working fine. You select everything in that table, which is principal, where the name ID is the ID that we were given. And we can right now go for a small break. If you're done eating, you can try to do the second part. A hint, we can have subqueries. So I'm not going to actually go over it right now. I'm going to go it after break. But know that in a in command, in var, you can actually do another query here if you put a parenthesis. So have fun and enjoy. What steps do we take if you start from here? Yes. Select star from title there. Yes. I'm just writing what you're saying.
From known for their name ID equal to the thing we have.
From known for does this work?
I would hope so. The semicolon, my God.
No, that's what would be the problem with this command, and how can we fix it?
Because it's the whole table.
Which one is whole table? So we have to change this. What should I change it to? Yes. And does this work? No result. Let me just double check the ID. Where is? Yep, the ID is there. Yes.
Okay, maybe I'm wrong, but I mean, okay, mine isn't working, but like we're just looking for a list of title IDs given a name ID. Can't we just look directly in known for? We don't have to go through title.
We need all of the information for title.
Oh, okay, we do. All right.
So what is the problem with this command? How can we fix it?
Separate question. What is the information we want to print out?
So we want to, each title in like each row in title has primary title, original title, is adult, a start year and end year. We want to print all of those for the movies that one person is known for, a specific person is known for. So real world example, I want to see in IMDb when you go to like, for example, character Johnny Depp, it shows the information. It says this person is known for these movies. I want to get that information. And small hint, this is very close, but has a small mistake. Yes. This part. Can you repeat that out loud? I can't hear you. Change this to title ID. Let's see. Correct. So these are the movies that first person Fred Astaire, something, is known for. Now, let's actually no. I'm not gonna do this. So I'm gonna actually show you the result here, which is exactly what we wrote down. You are very close, but make sure it shouldn't be star, and it should always be one column. Yes. Yes. So when you're searching for titles, some of the stuff that you can search for is like any information in the columns you can search for. But right now, what information do you have? The only thing that you can get from the known for table is title ID. So you want to use that. So you use the title ID and search IDs that are in title ID. And where do you get that title ID? Is from known for and the ones that name ID is specific thing. This one is a new type of condition. Technically not a new type, but it needs combining conditions. Which, by the way, in the where clause, we can have anything, and then we can have a condition, and then we can have and, or, and not. These are all acceptable, and they work as like exact English. And means both of the conditions has to be true, or all the conditions has to be true, or means at least one of them, and not means this condition should not be true. Exactly like programming. And the order is not applies first, then or, then and. Don't quote me on that. And you can always have parentheses. So parentheses still works in SQL. You can have two conditions in a parenthesis with and between them, and then the whole parenthesis with a or with something else. So your first part of the task is search for the titles that have a specific genre or a specific type. For example, I'm looking for movies that are both short and action. Something that I might go over today are these operators. You don't need them directly right now, but it's good to know. Even if we didn't get a chance to go over them, these are good to search about. Count, average, and sum. They work in a very fun way. Yes. Actually, wait a moment. Give me the query.
Select star
Okay.
from title where ID in parentheses select title ID from title to genre where genre ID is equal to
This one is ID or genre ID.
genre ID is equal.
Okay. Should I close the parenthesis?
And then semicolon.
But this is only giving the movies that have the genre 1. But I'm looking for the movies that have the genre 1 and have the type 1. So it has two conditions. This is all of the data that we have with genre being 1. How can I modify this command to add the second condition? Yes?
Just and at the end of the thing, and then it would be ID in open bracket, select title ID from Elias, where ID in open bracket, select.
Wait, I'm behind. Wait, I'm behind.
Sorry, I'm doing this. Okay, Elias, yeah, where ID in open bracket, select Elias ID. Wait, no.
Okay.
Never mind. Back up.
This might work, but keep in mind,
Yeah.
we're not looking for Elias type.
Okay,
We're
I'm
looking for
looking
movie type.
Yeah, but like Elias. Oh wait,
There's two types.
Oh, missed that. Ah.
But good idea. Overall correct. I think this should be the syntax where ID equal. No, actually, somebody give me the command for this part as well, because I have no clue how to do it. I don't have the database in front of me.
So select title ID from title to type, where type ID equals.
Let's see if this works. Did it change anything? Now is the time that I'm actually going to give you the notation of count, because right now we can't actually read all of this information. But look at this part. What if I write this? Any guesses of what would happen if I change the star to count ID? Anyone? What if instead of star I put count ID there?
I got an execute command denied the user error, but
Denied?
access denied to execute that command.
I got 1957 or 1957.
Everyone should have the exact same execution, unless you tried something like insert, update, delete, something to modify the server. Is your code exactly like this?
Yeah.
You're not getting denied, you are getting denied. So your count was the same?
Yeah. 1957.
Let's remove the and part and see if it changes anything. Yeah. So we actually search something. You can always use the count.
No, the count went up. Oh.
Yes. The count goes up to 4518. So this is using the count. What does it do? It just counts all of the records. What would happen if I do average on this one? Are you calculating it?
I mean, that's two guesses. I mean, the title isn't an int. So either it would just be like, oi, that's not a number, you can't do that, or else convert it to ASCII, I don't know.
But you're doing it with IO. Oh, yes, ID here is not int.
Yeah.
Makes sense. It's going to give you an error.
Okay.
Correct. I thought there was an int, and then I'm like, it should give us average. And then sum is just going to add them all up. I don't know how it does it with strings. Yes?
the problem was I was adding a space between count and ID. That gave me a denied access error, but when I took the space off, I got ID.
That I have. Oh, okay. So in MySQL, sometimes when you're running commands, if you add extra, if you call a column that doesn't exist, it tries to create that column for you. And that's what you're getting error, because it's looking for ID space and it can't find it. And don't ever name a column ID space. Don't put the spaces there. But now we have this crazy command. What would happen if someone become crazier and instead of giving us IDs, give us names? How many levels can we go? How many levels of subqueries can we go down? Is there a limit? We have one guess of infinite. I would assume that's another infinity, so 2 infinity.
Yeah, I think it just needs like another nest per condition.
So you can just go into nest for infinite times.
I mean, not
Infinite, not infinite, but as much as you want. Yes.
I'm going to say 4.
4 is max. Okay. What is the logic behind it?
I mean, what's the logic behind them saying infinity?
Okay, so the correct answer is actually infinity. And the logic behind it is the way that SQL queries work, they start from the inside one. They go the deepest, they ran it, they put the information to one up, then they do the one up, then they go back. Exactly. But there are some commands that are specifically designed for the top queries. Imagine this. This limit is actually running in the subquery. And the moment I ran it, it's going to give me this version of MySQL does not support limit on any, all, and subqueries. So yes, keep that in mind. For the next part of this, I'm going to go over something a bit new from the stuff we worked with, which is join.
great. Thank you so much. This is a ton of fun.
Bye. So we have join. What does join do? You still have a bit more time, right? Yes, we have 10 more minutes. I'm going to go over join really fast, and you guys, I'm going to send the slides so everyone can have access to it, and the platform is going to be all there like all the time. So the join commands attach 2 tables together and result to a table. If you've been in BO9, we have the similar type of join as a script. Yes.
When you combine the 2 tables, what happens to the 2 tables? Do they still remain the same, or you just get a third one?
So all of these ones are technically queries. The select, also the join needs a select command before it. So it's returning that result. It's showing you the result. It's not changing the database.
Oh, it's not, is it making a new table?
So in all of the select queries, a new table is getting created called res table or result table. This is only working on that, and that result table changes every time you run a different query. But how does this work? So this one is a bit more complicated. This is something that you actually learn it with experience. I tried several YouTube videos. They don't explain it that good. How does it work is we have 2 tables. Let's say title and name. We want to combine these 2. We want to combine them in a way that we want to combine title and known for. So when I search for known for information, I want to see readable results. Last time that we did it, we just see some title IDs and name IDs. That's not human readable. We want to make it human readable. The way that join works is, imagine these 2 tables are the ones that we want to join, and this is the resulting table. Table 1, table 2, and res as a result. We have technically 4 times of joining, but overall what join does is just combines them based on specific column. So as you can see here, we have select stuff from orders, inner join of customers, which is the other table, and then on something. This on something is the important part, because the on is telling which, let me just show it here. The on clause here is showing which columns do we want to combine. So let's say we have ID. This one has the exact same ID. And we say combine table 1 and table 2 based on ID and put them here.
So the rest table have a mental relationship to table 1 and table
we don't define relationships here because you're combining. You're putting information here and here. You're putting it in one. There's no tables that are getting connected. In the connections, we put an ID of one into the other one. In this one, we're not putting any IDs. We're just combining them into one table. So the way this one works is goes to the first ID, finds its match on this one, let's say this, and then put the ID one here, put the information of table 1 here, and then put the information of table 2 here. So the resulting table is going to have columns from both of those tables. But why do we have the inner join? That's where things get a bit crazy. We have 4 types of join. We have inner join, cross join, left join, right join. Yes. So the inner join only works when a record is found in both of them. So if you're doing the ID 1, it has to be in both tables to combine. The cross join doesn't care about it. It does all of the stuff from the first one first, then the second one, and then the combined one. So what it means is, imagine in table 1, I have ID 2, but in this one, I don't have any ID 2. In the cross join, it still puts this here. So I'm going to have a table ID 2. I'm going to have this information from table 1, but I'm not going to have any information for the table 2. The same happens for this one. If we have a tree, this tree is still going to get added here, and information of it is going to be here, and no information from table 1. Does this make sense? Then when knowing inner join and cross join, these two are easy. This means go with all of the information that are in table 1. So if you can't find the ID that are just like connecting those two, put the stuff from ID 1 with null values for the stuff for ID 2, for table 2, and don't put the stuff from table 2. In this one, it's the exact opposite. So the way we learn this is actually by practice. There is a test that is testing this exact problem. This one. So actually, I don't think that we have much time left yet. We have 4 minutes. So this is the task. Look at it a bit. I'm going to give you the code for it. You can take a picture and look at it later and try to understand it and try to do it yourself. The database design that we currently have is complicated enough that you can try to apply the same concept on this one on any other 2 tables. So the code for this is actually this. Oh, something to know. You can use the keyword as to change names, just temporarily, for your query to make it easier. So in this example, I'm changing the title to T1 and then again title to T2. So it's easier for me to understand. And then E to episode. So don't get confused with all of these notions. And at any point, if you want to point to a column from a different table, you say the name of the table dot the name of the column. So for example, the first one means E.id means E as in table E, which is episode, episode ID, which is column ID in episode. Everyone got a picture? I'm going to post it, but it might take a bit of time. So that's all for today. I'm showing you only this one because you can just, if it triggers your curiosity of what group by is, you can search it online. And group by is a way to actually group some records to make a central record for count, average, and these functions. You can test it out later and see how it goes. Overall, thank you for your attendance. I would really appreciate it if you fill out the form so I know how to do these better next times. And thank you very much.